Hey there, kiddos. In this video, we're going to go through the lesson of seeing how to solve the area of obtuse triangles. We've seen right triangles, we've seen acute triangles, and now we're going to be dealing with obtuse triangles. So we have this obtuse triangle, and if we remember, the word obtuse just means that this angle here is greater than 90 degrees. So whenever you're dealing with an obtuse triangle, it means that it's greater than 90 degrees. We're told when we're looking at this, we're given some pieces of information. We know that our base is that we can look at just half of this triangle. So from this dotted line here is 8 units, and this other part here is equal to 8 units. So we can either look at this as two triangles or just one large triangle. I'm going to look at it as just one large triangle. So I'm going to add these two together so that I can find the entire base, which is 16 units. And now the height of this triangle, remember, the height is always perpendicular, meaning that it's going to create a right angle from the base all the way to that top part. And here we see that that's 4 units. And so how we find the area of a triangle, of any triangle, in particular this obtuse triangle, is that area is equal to 1/2 times your base times your height. I hope all of us are remembering this, have this written down in our notebooks, and we just know that, hey, find the base, find the height, multiply those two, and then take half. And so we're going to multiply 16 times 4. 16 times 4 is going to give us 64. And then half of 64 is equal to 32 units. So this area of this obtuse triangle is equal to 32 units squared. We really don't want to forget this. We know that we have an assessment coming up. This will definitely be on the assessment in terms of, hey, make sure that your answer when it's coming to area is 32 units squared. And so we see that the instructions said that we could use two strategies. This is the first strategy. The second strategy is just saying, hey, if I just look at part of this triangle where the base was equal to 8 and the height was equal to 4, I could do the same thing with the other triangle where the base is equal to 8, the height is equal to 4. 8 times 4 is 32. Half of 32 is equal to 16. So we could just look at this as 16 units squared. And then we just add these two together. 16 plus 16 gives us 32 units squared, which is what we saw and calculated here when we were just able to add everything together or combine the two bases together to just have one long base. And so what's our key point for today? What have you seen with right triangles? What have you seen to be true with acute triangles? And what do you see is true also with now obtuse triangles? I hope you're saying to yourself that you see, hey, key point, write this down in your notebook. Yep, you guessed it. Our key point is that the area formula for the right triangle also applies to obtuse triangles. So we can still use area is equal to half of our base times the height. So we're going to still need to be able to identify what the base is, identify what the height is. And if we can know those two things, we'll be able to find the area. Let's have an example with our tested conjecture question. So we have the following. It says, what is the area of the triangle below? So first off, we need to identify, let's write out our area formula, which is 1/2 base times height. And when I look at this, I want to make sure that I am able to identify the base of this triangle, and I can also identify what is the height of this triangle. So when I look at this, I see this dotted line here. This creates a right triangle, but that's not my base. And I also see here that this and this creates a right angle. And so that means this measure here, which let me label that in purple, this measure here, this distance here, this part of the triangle, that's our base. So again, area is equal to 1/2 base times height. How do I know that this is my base? Well, again, like we said, because we see this right triangle or this right angle that's formed, and it goes to the apex or this part of the triangle, this is letting us know that, hey, this part here This 10 meters and 8 meters, or 18 meters, that's our base. And then this distance here is our height, because it goes from the base at a right angle to the top point, so that's 6.1 meters. So our base is 18 meters, and our height is equal to 6.1 meters. All right, don't let this dotted line here, don't let this, let's put this in, let's go in yellow. Don't let this part here fool you into thinking that this is a height. It's true. The height from this point all the way up is 6 meters, but it's not the height of the triangle. Alrighty, it's not the height of the triangle. The height of the triangle is equal to 6.1 meters, because that's the vertical distance between the base and that opposite corner, or that opposite vertex, vertex being the mathematical term. Now, when we multiply our base times height, what do we end up with? We get 109.8, and then half of 109.8 is 54.9. So the area of our triangle, because the units here are meters, would be 54.9 square meters. We'd never want to forget this last part here with our square meters, our square units. In this case, they're meters, so it would be 54.9 square meters. Fantastic. Now, let's get to our partner practice.